following will cover basic user programming of the drive's internal indexer program. Follow-along labs will be presented to familiarize the user with the SML programming, or simple motion language. These labs build upon each other. It is recommended to perform these labs in sequence. The drive uses its internal variables as its internal reference. The internal setting for reference on the parameters section of the navigation tree is used when the drive will either be commanded by user logic using its indexer program or by messaging from a master communicating over a network. The indexer program allows the position servo to make logical decisions and execute motion commands. The indexer program is written in a basic-like language called simple motion language, or SML. As with most basic-like languages, the user can define any constant or variable. They can assign names to any constant, variable, input, output, or event. This is commonly called aliasing. Labels can also be added to any section of code to facilitate program development and program execution, i.e. the goto command. The commands shown on this slide are used for basic logic decisions. The commands on this slide are the basic motion commands in SML. These are the basic system variables in the drive. The drive is also capable of basic mathematics and also basic comparison logic. Boolean logic instructions are also available. These are often used in conjunction with drive system flags. On this slide, we see the drive system flags. The indexer program is accessed in the navigation tree as shown. The indexer program itself is displayed in the parameter view window of MVOB. The indexer program has its own set of control buttons. These control the actions of MVOB's compiler. The compiler control buttons are Compile, which compiles a program to check for syntax errors. This button does not actually load the program or program changes to the drive. Load with Source. This button compiles the code and then loads the program to the drive. Load without source compiles the code, loads the program to the drive, but it does not load a source code copy to the drive. As a result, users logging into a drive that has had its indexer program loaded without source cannot see or edit the program. This feature is particularly useful for OEMs wanting to protect their intellectual property. Reload uploads the indexer program from the drive to the screen. This feature is useful if a user changes his mind in the process of editing an existing indexer program. The Export button exports the indexer code to a TXT file. The Import button imports an indexer program.txt file to the editor. Run starts the indexer program execution. Reset resets the indexer, wherever it is in Solve, to the top line of the program. Pause stops the indexer program execution. Step allows the user to step through the program execution one line at a time for debugging or troubleshooting purposes. The Clear button clears the indexer program from the screen. Lenze Americas recommends users follow good programming structure and provides example templates in the technical support library of the lenzeamericas.com website. Programs should first contain a header listing the title of the program, the author, as well as a commented revision number and date, an I/O listing for the machine, definitions of user variables, and then a definition of all constants used. Here you will see a basic header, I/O list, and initialization and setting of variables. After initializing and setting variables, the next element of the program structure is to define all events. Events are a deterministic task that solves independently of the main program. Events are not interrupts. They are scanned every 512 microseconds to see if they are true. While they cannot be used to trigger a goto statement, an equivalent command which can be used within events is jump. Here we see programming structure of where events are defined immediately before the main body of the program. The main program is followed by subroutine definitions and then a fault handler routine. The main program is the main body of code. This can include any motion commands, logic statements, math statements, labels, or subroutine calls. the main body of code must be finished by an end statement. The SML language includes very easy to use and understand logical statements. For example, if, else, and if, do, until, while, and while. Of these, the most commonly used statement is the wait command. This is used either to wait until a condition occurs, wait while a condition is present, or wait until a time period elapses. That time period is always in milliseconds. Another commonly used element appearing in virtually all user programs is the goto instruction and labels. Uses of this include allowing program loops to be written. The motion commands simply put command the axis to move. We will now discuss each type of move command individually. Move D is a displacement move. Move D3 would move forward 3 user units. Move D -5 would move 5 user units in the reverse direction. Move D back 5 would also move the drive in the reverse direction 5 user units. These are all incremental moves and just move the program distance from the current location when executed. The move P command is move to absolute position. Absolute position should first be established by homing the drive at the beginning of program. The position servo also features registration moves, move DR and move PR. Also it features move until condition, move until, move while condition, move while, segmented moves, MDV, and it can also perform SRAMP acceleration and deceleration for any move type. Simply add "S" to the end of any move command to add SRAMP acceleration and deceleration. Here you can see a very basic indexing program. Note that even though the goto statement is used to loop the program endlessly, the main program still is finished with an end statement. Subroutines are programmed after the main program body. Subroutines can nest 16 levels deep. The command gosub is used to trigger the execution of a subroutine. Subroutines use the return statement to note their end and to send the program execution back to the main body of code at the line immediately after the subroutine was triggered. Subroutines are very useful when a section of code must be repeated multiple times within the execution of a loop of the main program. As you can see from this slide, subroutines are coded after the main body of code in the indexer program.